So this is video number 70, and well, I'm going to talk about programming, again my translations from the past, I think a little bit of mathematics, so let's go. And I'll start with the poems, the translations. Finally I decided my desire, my inspiration to translate my favorite poems from Russian into English finally came to some halt, because I translated almost everything I knew in Russian and what I liked. That's why now it's time to edit my translations, so that, for example, all the first letters of the lines were changed from the small letters into the capital letters, and of course I need to put some punctuation signs like dots, commas, and other stuff. And yeah, I'm going to publish these poems in my Instagram, so that I have the collection of my translations in one place. And the first poem that I decided to publish, and which I edited, is Pushkin's Lukomoria. So let's go. The great green oak grows in the harbor, the golden chain hangs from the tree. From dawn till dusk, the science lover, the clever cat, walks on the stream. He sings the song while walking forward, he tells the story walking back. There all the marvels are mind-blowing. The mermaid sits upon the bank. There are the traces of the demons along the overgrown old tracks. The hut, which has no doors and windows, stands on the monstrous chicken legs. There woods and fields are full of wonders. There, at the threshold of each sunrise, the waves rush forward on the coast, and 30 knights in their bright armor come in succession from the harbor, and their commander marches first. There, in the meantime, one fierce baron is captured by the fearless knight. Up there, the wizard, like a raven, holds up the princess in his talons and carries her across the sky. Imprisoned there, the maiden sorrows, her yesterdays like her tomorrow. There, Baba Yaga's motor strolls, all by itself, without control. There, Tsar Koshchei will always fear it, the scent of mighty Russian spirit. And there I was. I drank the mead, I saw the oak tree at the harbor, the clever cat, the science lover, told me his stories of great deeds. Okay, next will be my new translation of the humor poem of some anonymous writer, but it really sounds cool in Russian, and I hope that my translation preserved the same humor mood. Let's go. I trust a president is decent, and nobody can bribe a judge, and the police protects the weakest. I trust the orcs are green and large. I trust we paid fair for our labor, and our best country growth to be, and my dear wife with my friend neighbor will never ever cheat on me. And I believe the fortune teller who takes my money as her fee, that I'll become the richest fella, and I'll be happy, fit and free. And I believe my children's teacher just doesn't want to take a bribe, and she's a rare endangered creature who teaches for her moral vibe. and the insurance institution where all the clerks say with one voice of making all the restitution is trusted. Do I have a choice? And I believe the politicians, the Duma deputies' bright minds, the premier with his greater mission, or those who robbed the country blind. And I believe all the injections and all the tablets that I take increase my strength and motivation, so I'll survive for my own sake. I have no doubt about those persons, about the care and politics. I know this all is a rehearsal for our play life in Chamber 6. Okay, it was not so bad, but I read it aloud maybe like for the first time, so the pronunciation is quite bad, okay, with this lots of stops where I'm not sure what to say next, even though I wrote it myself. But you know, when I rewrite the first idea that I had, because I need to be more close, because I need to be closer to the original text, then I just forget what I invent, because sometimes I have like 10 different lines, and then I choose the 11th line, so I really don't remember what was the last line. Okay, finally I made the translation of Цветаева's «Мне нравится, что вы больны не мной», but my first version was not very cool, though it was grammatically correct and it was alright, everything was alright with the rhythm, but it was kind of too far from the original poem, and I rewrote some parts of the first what is this verse, maybe. The poem consists of 3 verses, so I rewrote the part of the first verse, and I rewrote one sentence from the second one. And now I will read it aloud. I like it that you're not obsessed with me. I like that you're not my obsession either, and that the heavy globe beneath our feet will never slip away to the horizon, that I may pardon my female appeal and be ridiculous and you don't bother, and that the blush will never fill my cheeks in moments when our sleeves will touch each other. I also like that right before my eyes you quietly embrace another woman, that you don't prophesy my soon demise for kissing someone else, for my impudence, that you won't call my name 1,000 times, all day and night, forgetting all your prudence, and that before the altar we won't plight a troth to pledges of to loving humans. I thank you from my heart and from my soul, for loving me not even realizing, for my night rest habitual and whole, and for the stars we cannot have our eyes on, and for the moon which doesn't light us trolls, for someone else's dates full of surprises, for me with whom you're not obsessed at all, for you who isn't my obsession either. Okay, so again, this is my translation, and even right now I see some stuff where I can change a little bit of text to make it more fluent, though the whole idea will remain the same. And in the end, the last version of my translation of Akhmatov's «21 ночь в понедельник». In the night, like in Hoffman's Nutcracker, the metropolis contours unfold. It just happened that some local slacker thought of love to be found in the word. Being bored or just being too lazy, everybody believed in this whim. They await every meeting like crazy, feel the partying and sing their love hymns. But the mystery opens to others, and at once they become calm and still. I just stumbled on it with no bother, and since then I felt like I've been ill. Okay, so it was my last poem for today, and now I'm going to switch to, again, my practice of the programming. My practice with the programming, where I just read aloud the information. My scripts, and I try to get the idea behind the script from the code itself. Let's go. Level 6 task, triangle number check. So if I knew what is the triangle number in mathematics, I would say what this task is about, but because I don't remember this stuff, I'll just go through the code again. We have the function isTriangleNumber. It takes one parameter number of type int. It returns bool variable. First we check, we have two guard statements. In the first one, we check that number is not equal to 0, otherwise we return true. So 0 is a triangle number. In the second guard statement, we check that number is not equal to 1, or we return true, which means that 1 is a triangle number as well. Next, we initialize some variable as 0 with 0, and we go through all the natural numbers from 1 till the number which precedes the number which was given to us as a parameter. And what do we do? Okay. We calculate the... Okay, yeah, I see. We calculate the arithmetic progression for each natural number from 1 to why 1? We have this not equal to 1, so we should do this from 2. But if this is 2, okay, let's go. We have the arithmetic the sum of the arithmetic progression. Yes, and if this sum is more than or equal to, is greater or equal to the number itself, we break through the cycle, and then we return the bool statement that the last sum that we calculated is equal to the number. Well, it's not very difficult to implement, but it's kind of hard to understand what was the logic behind the task from the code itself. Next, we have something like Fibonacci. Fibonacci function takes two parameters, the array of ints and just an int, and the function returns the array of ints. So in the get statement, we check that n, which is int, is greater than 3, otherwise we return array. Okay, otherwise we return first n elements of a signature array. Like for 1, for 0, I'm not sure if the 0 is a valid number, but for 0, no, I think it's not valid. For 1, we return the first element. Yeah, for 2, we return 2 first elements. For 3, we return 3 first elements. We have this Swift, not feature, but it's the syntax, let's say, feature, because when we take when we take the range from the array, we have something like subarray. It's not the array itself, so we need to convert this value that this type that we just returned into array, so that this returning type was consistent with the returning type from the function. Then we create array A, which consists of zeros, of all zeros, and its size is equal to the size of the signature array. Yeah. No, I'm not sure about the signature array, but at least it doesn't matter. So some n is the size of our new array. And then we initialize the first 3 elements of array A, of the array A. Yes, the array of A array with the first 3 elements of the signature array, and then we go through all the rest of the elements. I go through all the rest of the elements of the signature array, and we calculate each next element of A array as this Fibonacci stuff, the sum of the previous and previous elements of this of itself, and in the end we return the array n. So I think the task was something like we have some signature as the parameter, and we have n as the number of elements that we should calculate, according to this Fibonacci rule from the initial signature array. And that's what we do in this script. Let's go to sum. To sum, we have a solution class with one static function. To sum, I think static function is the function of the class, so we can call this function directly on the class, like solution dot toSum. toSum takes two parameters, numbers, which is the array of doubles, and target, which is the double, and then toSum returns the array of ints. So we go through all elements of numbers array, of the numbers array, and we get the first something, which is I think target is what is, I don't know, target something for E in numbers, first index of target minus I. Okay, let's say we have the first element from numbers, then we take target and subtract then target, and we subtract I from this target. We find the index, first index of the result, and this is the first something. And then we search for the last index of this element I, the last occurrence of the element I in the array numbers, and this is the last. And then we have this conditional statement if. Yeah, because first and the last are the optionals of type double, like double question mark, because in the case we don't have these elements, first and the last will be just nil. So we have this optional binding inside the if statement condition, okay? Like if let first equals first, this way we define the constant first, which is of type double. And this construction is used to implicitly unwrap optional first and assign the double, which is inside this optional, to the variable, to the constant first. We do the same stuff with the last. We get the double from the optional, and then we check that first and the last should be not equal. And in this case, we return array consisting of first and last sorted in the ascending order. So the minimum element, the last element goes the first, and the greater element goes the last. If we don't meet this condition through all our check, through all the elements in the numbers array, we just return the empty array. Okay, I just wanted to check how much more how much more scripts I should comment, yeah, and they're quite a number. So level 6 valid braces. We import foundation maybe because we will use some specific functions from the libraries that are inside foundation. We can't just use all the libraries from we can just use the tools of the Swift language alone. So valid braces function takes one string parameter and returns bool parameter. We define the array. We define the dictionary of valid pairs, like close. The first, yes, the value corresponds to the key. So the open paren corresponds to the closed paren. The open curly bracket corresponds to the close curly bracket, and the open square bracket corresponds to the close square bracket. Then we define stack, which is the array of strings. Okay, and we take this. We take the string parameter and convert it into the array of the elements to the array of the characters of the string. And because the condition was that only this valid, that only parentheses, different types of parentheses will be put into the string, we name this new array braces. We go through each brace in the array. Okay, string brace. Yeah, first we convert the brace character of the string into the string type brace, and then we have the switch statement. If we meet the open paren of one of these three types, we put it on the stack. Then if we meet the close paren of these three types, then we have several actions, like if stack is empty, then we just return false, which mean that having the close paren before the open paren is the false string. Okay. Otherwise, we remove the last. Otherwise, we remove the last element from the stack, the last open paren from the stack. We remove it from the stack, and we get it in the variable, in the prev brace variable. Next, we check that this prev brace variable contains the valid open paren according to our dictionary. If it's not, we return false, that the string that was given to us is invalid. And of course we have this default case which returns false, which means that if the element in the string is not one of these 6 valid types of braces, parens, then we just say that the string is invalid. Yeah, and in the end, we return the state of the stack. If all the closed parens met all the open parens, then in the end the stack should be empty, and we just return this condition. If stack is not empty, then again the initial string was not valid. Okay, let's go. Which are in function in array takes two parameters of type the array of strings, and it returns the array of strings. From first we define the set of strings, then for each element in the first array, for each string, which is subword, okay, for each word in array, in A2 array, we check that if word contains subword, then we insert this subword in our set, and we break the inner loop, and next we take the next subword from the first array. So I think the idea is that the first array contains subwords of some word from the second array, and maybe, yeah. And if it is true, then we add this subword to our output set, and in the end we convert the set into the array, and we sort it in the ascending order. So in the end we return all the subwords from the first array, which can be found in the words from the second array, but now they're sorted in the ascending order. Okay, next we have these balanced numbers. I don't remember the idea behind them, and I have two my own solutions and one best practice. So let's go with my own solutions. It's quite long, but it's easy to read. So we have the number of type int, of the int type, Okay. Number. The function. Yeah, it's not so popular. So what we have here, while number is positive, we get the remainders after the division by 10. So obviously we get the numbers, the individual digits from this number, but in the reverse order, like the last digits, the previous, Yeah, and then we put in the array the first digit. If there are only 2 or 1 digit in this number, we say that this number is balanced. Then we do some calculation, like if number of elements in array, if number of digits of the number is what? Is even, then we calculate something to left, like array count divided by 2 minus 2, otherwise like array count by 2 minus 1. I think we try to take some middle element according to our rule. We have left sum, which is equal to 0. Okay, so now we have the count from 0 to this to left I don't know, index number or something, and then we calculate the left sum, of the digits, and again we have the right sum, and then we calculate the right sum of the digits. Okay, and if these two sums are equal, then we say that the initial number is balanced. If not, we return that it's not balanced. So I see now it's quite a straightforward logic, but it took me lots of lines to write, so it's kind of difficult to read it at once to understand the logic behind it. So there is my own solution, which consists only of 3 lines. Maybe it's more difficult to understand, but it's more concise. Let's go. First, we create this array. As usual, we take the number, convert it into string. So if it was 1 to 3, we have the string 1 to 3. We map each character into int, like each character into int. First we convert the character type into string, and then string into int. We know that int that all the elements of the string are digits. So usually I use force unwrapping, but it's not the best practice, and the better practice is to use this, I don't remember the name, double question sign operator. So if if the element inside the element inside int optional is valid int, then this operator just returns it. If it's nil, the operator just returns 0. But because we know that the initial string contains only the digits, then we always get the int elements, but in this case we don't use this force unwrapping. This is an interesting syntax sugar. I should remember it for the future use. So we turned the number into the array of its digits in the right order. Next, we calculate the right sum. I created, I'm not sure how it is called, the block of code, maybe the closure, which takes one parameter array of ints and it returns int, and we do this calculation like a count, the same stuff I did when I calculated the right sum of the array. So we get the right part of the array and we reduce it. We calculate the sum of the element of this right part, and this way we get right sum. No, we have only the closure, and then I do this comparison when first I apply, or maybe first I pass array to this right sum closure, and then I pass array reversed to this right sum closure. This way this right sum closure calculates the left part of the array, but because it was reversed, it calculates this left part, which became the right part. And if these two sums are equal, we use the ternary operator to return balanced or not balanced. It's quite difficult, but it's quite logical. And in this number of elements to compare, and we have the best practice, the best practice number array. I'm not sure about this, but we calculate first half as array of ints. Yeah, it's what I get when I converted the number into the array of its digits. We take the prefix, the number of elements we need to compare. Somewhere we should calculate it first, and then again we take the suffix of this array. The suffix means the right part of the array, prefix means the left part of the array, and we calculate the sum of this subarray, and then of course we compare and return the result. Well, it's easier to read because the prefix and the suffix are two library functions which are always in the language, so it's better to use them than to calculate my own. Well, I can write my own code at first, but then I need to switch to the library function because they are always better. It will be easier. Level sum, billiards triangle. So, wow, with this I can say, yeah, it was a balanced number. With this I can say that finally I ended solving level 7 functions or tasks and level 6 tasks, and I switched to level 7. So billiard triangle is the second task in this level 7. So function, the solution looks quite easy. So I take the pyramid function, takes one both parameter of type int, and it returns the parameter of type int, and we start with 1, while sum less or equal to both, we increase level, and we calculate the sum like level plus 1, and we just return level. I'm not sure about this stuff. It sounds quite simple. Maybe it was about the logic behind the code than the code itself. I think with this I'll stop. I stop on describing the programming, and I think I'll return a little bit to just talking on some topics. And in the last topic that I found quite interesting is about describing basic mathematics. I found the grammar book when lots of specific words that form specific plural forms were collected together, and one of the words was axis for the one element and axis for the number of elements. So if I studied mathematics maybe in the 3rd grade or maybe in the 5th grade, where I would have been introduced to I would be introduced to this what is this coordinates grid, then it would sound like something like this. So first we write the horizontal axis and the vertical axis. These two axes should be perpendicular, and the horizontal axis, which we denote x, should divide the sheet of paper into halves, and of course the vertical axis should divide the list of paper into halves as well, the sheet of paper into halves as well. Then we can see that the point when these two axes crossed is somewhere in the middle, in the center of the page. We name this, we denote this point as maybe the beginning of the coordinates, and we write the pair of numbers 0 and 0, 0 for x and 0 for y. Yeah, the vertical axis is denoted as y. So the x-axis denotes the numbers that go from the left, the number the number row that goes from the left to the right. So in the left we have negative numbers, and to the right we have positive numbers, and the arrow shows the direction from negative to positive numbers. And the same goes with the y-axis. It denotes the numbers from negative to the bottom to positive at the top, and the arrow shows the direction to the top. These two axes divide the plane into 4 quadrants, and we denote them as 1, 2, 3, 4, starting with the quadrant with positive x numbers and y numbers, and then going clockwise. So the second quadrant will have the negative x numbers and positive y numbers. The third quadrant will contain negative x and negative y numbers, and the last fourth quadrant contains positive x and negative y numbers. And now, having prepared this grid, this grid of coordinate grid, we can draw the graphical representation of some functions that we used. Like, the simplest function is the linear function x equals y equals x, which means so mathematically, in mathematics, the function shows the mapping, or the function maps the elements of one set to the elements of the other set. So when we have the function x equals y equals x, it means that the elements of set of x set are mapped to the elements of the y set. And in this particular case, and the function f, so we can write something like y equals f of x, and the function shows the rule how this mapping occurs. But in the simplest case, when y equals x, this function rule is just equal to 1, and then we just take any number from x and it maps to the same number of y. And that's why when we draw this line on this coordinate grid, we have the straight line that goes through the third and the first quadrants, and it divides the angle between these coordinates, or between these two axes, equally. Like, the angle from between this line and the x axis equals just equals 45 degrees, and the angle between this line and the y axis equals 45 degrees as well. This is the simplest, I think the simplest, well, it's not the simplest possible function. The simplest function when we draw the constant, like x equals 1, which means that all the values from x set maps to some constant, like 1, for example. And when we draw this constant, the graphic of this function on the coordinate grid, we have the vertical line that goes parallel to y-axis and which crosses the x and which crosses. So yeah, in the case of I am not sure, this is not the function maybe, because when y equals to 1, then y equals to 1, or maybe that's true. When y okay, I remember now. Something like yeah, I remember this stuff. We say that something is the function when each element x corresponds to corresponds to only one element of y set. For this reason, we can't think of x equals 1 as a function, because in this case x element 1 maps to all the elements of y set. But we can say that y equals 1. In this case, we say that each element from x set maps to only one element from y set, which is 1, for example. And then we write, we draw this straight line that crosses x at the point with the coordinates 0, 1, and which goes parallel to the x-axis. Wow, that's cool, really cool. Maybe I will get some information about this basic stuff in English, and then I can describe some stuff like the behavior of simple functions, linear functions, or maybe parabolic functions with different coefficients later. But for now, I think that's all right. And this is the end of my video 70, right?